All right, good morning, ladies and gentlemen. Welcome to week 11 of SAT Math Prep. Welcome back for second semester. And in general, just welcome back. We are about 8.5 weeks away from the SAT, ladies and gentlemen. And if you are a junior, that means we are about 8 of these lessons away from the entire series being complete. So we're going to see some formatting changes here in second semester as we attempt to adjust the program to make it more effective. Starting with, you'll notice that your paper that is in front of you is only the guided notes paper. The skill check is now a separate sheet of paper, and you will not be receiving those problems until you have finished watching the video. Again, the idea of the video is that we are going through some tips and tricks, some details that you may or may not see on the actual SAT. And if you don't pay attention during the video, you're not going to get anything out of it. We're doing a topic this week that everybody should be relatively good at, that is interpreting linear functions. Doing things like looking at an equation and deciding what a number means, or deciding what an input and output mean together, or plugging a number in to find another number. So we're doing skills that we have lots and lots of practice with throughout high school. But now we're looking at it from an SAT standpoint. We're focused in on the vocabulary and what little details do we need to see in order to pass the SAT. So make sure you get your full name on your paper, first and last name. Make sure you circle your teacher's name and your class that you are in. And let's get down to business. So we'll start with, again, notice it says write down all the information added to the notes. So here on example 1, it says the speed of a sound wave in air depends on the air temperature. The formula below shows the relationship between A, the speed of a sound wave, in feet per second, and T, the air temperature, in degrees Fahrenheit. A equals 1052 plus 1.08 T. Then the actual question is beginning now. All that was just description of the equation, of the situation, and that's very common on the SAT, for them to have a long worded explanation that you need to read because there are several important details in there when we go to answer the question. It says, at which of the following air temperatures will the speed of sound wave be closest to 1,000 feet per second? So what they've given us here is they have given us an airspeed of 1,000 feet per second. So A is 1,000. And they're asking us, what is T? So we're going to plug that 1,000 in for A, which would give us the equation 1,000 equals 1,052 plus 1.08 T. And we are then going to solve that equation for T. So that's a two-step equation. The first step is to subtract 1,052 from each side of that equation, which would give us negative 52 equals 1.08 T. And then to get T by itself, we need to divide by 1.08. So when we do that, we get, I'll grab my calculator here. All right, let's see here. Negative 52 divided by 1.08 is, T is actually equal to negative 48.148 repeating, which would be closest to negative 48 degrees Fahrenheit. Okay, again, that's the key word there, is closest to. And closest means we should be rounding this answer off, and we should be running with negative 48 degrees Fahrenheit for the example of 1. So again, you're going to see those words, closest, at most, at least, no more than, no less than. These are words that the SAT is going to use. And what that's telling you to do is to round. In fact, it's telling you how to round. It's saying, is that decimal, negative 48.148 repeating, is that closer to negative 48 or negative 49? The answer would be negative 48. Okay, on to example 2, which I'm going to have to center on the screen here. Okay, it says, and this one's really, really wordy, and it didn't print very well, so hopefully you can read it on your paper. In 1919, H.S. Reed and H.R. Holland published a paper on the growth of sunflowers. Included in the paper were the table and graph shown below, which show the height, h, in centimeters of a sunflower, t days after the sunflower begins to grow. So there's a table, there's a function, in the graph there, notice that the y-coordinate is the height and the x-coordinate is days, or t is days. In this case, they're using t instead of x. So see the t-axis and the h-axis, okay? So your independent variable is t, and your dependent variable is y. Then it goes on to actually ask a question. It says the function h defined by h of t equals at plus b, where a and b are constants, models the height in centimeters of the sunflower after t days of growth during a time period which is approximately linear. Those are some key words right there. Because as soon as you see that, you should be thinking slope-intercept form, y equals mx plus b. But in this case, notice the variables are not the same. It's not y equals mx plus b. It's h equals a t plus b. Okay? So the only variable that's the same is b. B is the y-intercept. And a, it says, what does a represent? Well, a is your slope. A is your rate of change. A would be a rate. It has to be a rate of change. So when we go to look at our answers, 3 of the 4 answers are eliminated immediately because B says the predicted height at the beginning. That's not a rate. C says the predicted height at the end. That is not a rate. And D says predicted total increase. That is not a rate. It has to be a rate of change, which means the answer has to be A. All of that wording, all of that reading is unimportant if we recognize the structure. If we notice that h of t equals at plus b is the same as y equals mx plus b, and realize that a has to be the slope, has to be the rate of change. Because remember that rate of change has to have each or per in the answer in order to be a rate. You're looking for those key words that indicate a rate of change. Okay, and notice we didn't even need the table. We didn't need the graph. They're there as distractors. They're trying to make you overthink. All right, let's go to example 3. It says in the equation shown below, and I've opened up the wrong version of it. Let's find the right one here. Here it is. In the equation shown below, there it is, T represents Brittany's total take-home pay in dollars for her first week of work, where H represents the number of hours she's worked that week, and 1,000 represents a sign-on bonus. If Brittany's total take-home pay was $1,576, for how many hours was Brittany paid in her first week of work? So there's the question we're actually trying to answer. We're trying to solve for H. So what we're going to do is we're going to take this number here, which is her total take-home pay, meaning that that is going to be our T value. We're going to plug that in for T. So that would be, give us the equation, 1,576 equals 1,000 plus 18H. And notice that that is only one variable, so at that point we should realize that we need to solve. So we would subtract 1,000 from each side, which would give us 576 equals 18H, and then we would divide by 18, which would give us H equals 32 hours, which means that she worked for 32 hours in that first week. So again, we have practice with solving these linear equations. We've done a ton of it this year, previous years. The math itself is not difficult. The hard part is going to be, are you disciplined enough to read the question and pull the correct information out and use it in the correct way. So at this point, your proctor is going to pass out the skill check sheet. It is two-sided because these are such wordy problems. There's only 5 questions, 4 questions, somewhere in there. Okay, but you need to read through the questions carefully, identify the question that's being asked, and then ask yourself, how do I solve the problem? So again, hopefully this guided note page here will be helpful. These 3 examples will be helpful in helping you solve the other 5. When you have completed the other 5 questions, or when the period ends, make sure your name is on both papers, the notes and the skill check, and turn them in to your proctor, who will return them to me. Thank you very much for your time and attention. See you next week.